So this one we actually have two ways we can get there, so I'll show you both. We could treat it as a factoring problem. This would be of the form a squared minus b squared. And remember that when we have that difference of squares, it's going to come out a plus b and a minus b. So factoring, I would get, I'll just come down here with it, my a would be 4x, because 4x times 4x gets me back to that 16x squared. So 4x and then plus 5. Oops, I do not mean that squared, sorry. And 4x minus 5. So a plus b, a minus b. And then with that, I can just set each of these factors to 0 and solve. And so here I would bring over the 5, I would get 4x equals negative 5, and then divide the 4. And I would get x equals negative 5 fourths. And then when I do the same thing on this side, I'll get positive 5 fourths, because I add the 5 over now. Divide that 4. So that's one way. The other way would have been to bring the 25 over to this side. And the reason I can do this comfortably is because I can isolate this square. And if I can isolate a square, I can take the square root of both sides. So bringing the 25 over would get me here, and then I'll go ahead and divide both sides by 16. So I'm getting that square all by itself. So that's gone. Now I have x squared equals 25 over 16. And now I can use the square root principle. I'll root both sides. And then here, be careful, that's usually where people mess it up, is they square root both sides and then they just write down the positive root. But that has two answers, because we saw over here it has both a positive and negative. So x would equal plus or minus 5 fourths. In other words, positive 5 fourths and negative 5 fourths. So for that particular problem, there's two ways to get there, and they are both equally good, so pick the one that you like.